First important thing, this was not a financial engineering story. This was a genuine effort to put two major companies together and create a more than $10 billion company. We didn't do it to prune the portfolio or to optimize the financial return from pieces of the portfolio. We did it to become a bigger company and to grow faster than our competitors and to be in the top league of semiconductor companies that influence the market. That really was the thought process throughout. So you'll see us continuing to invest. When you get big mergers, sometimes you get rumors or even realities of portfolio pruning or merging of processes, optimizing costs in a factory. Well, right from the beginning, we knew that all our factories were pretty much fully loaded. All of our product lines were pretty much at maximum output. And we saw no reason whatsoever to start planning any reduction of manufacturing facilities either then or even now a year later. I can commit to you that we have no plans to reduce portfolio, no plans to do any cost saving that impacts the growth of the product families. In fact, our objective is solely to look at all of the new IP that was being developed on both sides and make sure we leverage it into both families. Now, we're acutely aware that developers are dependent on the development tool environment, dependent on many, many underpinning things of the platforms that you work on. And so we're committed to continuing both roadmaps. And when we do finally shape it into a combined roadmap for MCU, we'll figure out the best ways to keep future technologies going. I can tell you from that very first discussion in December of 14, our entire conversation was about creating a bigger company, 2x the size, getting to be the same scale as TI, recognizing that it puts us in the top 5 of all semiconductor companies, but that the number 1 and 2, Intel, Samsung, are pure play processors or mobile to a certain extent. But TI and ourselves are the 2 big broad semiconductor vendors. And it changes the nature of NXP Freescale. Don't think of it as like bringing the ON portfolio back to Motorola. Think of it as NXP having a large range of vertical solutions with pure play standard products. Adding that to the Freescale embedded processing portfolio, which was nearly 75% of the entire portfolio, and adding on things like network equipment processing. And as you'll see, we go from end to end, from edge node devices all the way to the cloud with networking competence, connectivity competence, and most importantly for the future, security competence. 80% of my business through the distribution partnership. And not just distribution partners for supply, technical support, and customer relationship, but also a huge range of ecosystem partners. Whether it's tools or enablement or adjacent technologies, that's also another crucial area of activity with our distribution partners. So it's an influence far beyond the 5.6 billion because of all the other ecosystem partners that it brings together. And I think that distribution is the glue, it's the hub of that activity to the market, where we bring small partner customers or small partner vendors together with our technology and bring it directly to the customer. So these are some of the examples. We've just picked some of the vertical solutions now that the new company addresses. And you look at the portfolio we have, from application processors to network processor to microcontrollers to connected MCU, connected dedicated solutions for BLE and Zigbee, as well as sensors, mixed signal analog. A vast range of solutions from the one company. And I mentioned we're prepared to acquire more, we're prepared to develop more, and we will continue to invest in this area, particularly with a view to improving security and privacy and ensuring interoperability seamlessly. The technology areas that we're investing in are pretty much summed up here. I was at CES in the first week of January, and CES used to be a show where 130,000 people came to look at the latest consumer products. And this year, 170,000, and as far as the eye could see, it's become about the connected car. And the connected car really is a symbol of the connected everything. The progress in that space is just tremendous. But along with that connected concept comes the problems of security and privacy. And that's an area where NXP had made huge progress in identification security, in privacy of documents. Everything from supplying more than 100 countries with their e-passports, government documents, transportation, payment systems, mobile banking across many regions. And from the Freescale side, you have high-level, cloud-based network equipment security. Okay, so what are the core competencies that both companies have been working on the last few years, and why do we think it's such a good fit? Well, pretty much you can look at this, embedded security, and say that's kind of like the centerpiece of what we've been doing. Whether you look at the activities from NXP in the area of smart cards, mobile payment transaction, e-passport, everywhere where you've got the need for secure access to data, document, transactions, the NXP's been a powerhouse in this field. Over the last couple of years, we've seen a huge expansion of connected microcontrollers for IoT solutions. Research we've seen, and even empirical evidence just going to customers, we can see the impact of startups in this area. Research shows that more than 50% of IoT products over the next years will come from startup or single individual customers today. It's a remarkable change in the way products are developed. The problem is security and privacy are low on the concerns of customers trying to get products to market quickly. I was with our senior fellow of security last week in the Paris Roadshow, and you basically have to accept that you cannot have total security. You have to accept that if you put huge amounts of data in one place, you make it very, very attractive for people to try hack. One of the possible countermeasures is actually to distribute that data into smaller and smaller pieces over more and more and more locations, so that each individual target becomes less valuable and the number of targets increases to the point where it becomes less viable. And you have to make sure that once you have a point of entry, the way that you were able to break into that cannot be stepped and repeated for all the other network nodes. So when you see some of our architectures, you're going to think, well, why aren't they doing even more lockdown security on the central database? And that's one of the reasons. It also goes hand in hand with the idea of not overloading the global networks with massive amounts of data which all get loaded into one central place. And we have to take that large scale and we have to take that down to the individual $1 device and figure out how to make pieces of that relevant and how to make the way we structure data and the way we help you build data systems be more immune from attack, less valuable to the attacker. I keep stressing that because you have to think about that when designing a security system to try and make pieces of your network less valuable to the potential attacker. I think in security, it's clear that we're going to have to offer everything from security enablement as standard all the way through to professional services to make sure that networks are as protected as they can be, and that the security software combined with the hardware we do is continually evolving to match the threat. And this applies to the microcontroller space as well as the application processor space. And the skill set of NXP and Freescale combined is second to none in the industry here. So if there's one message I have for you today, it's everything from passports and transportation systems, which have defied hacking over the last 7-8 years. Anything you read about 5 years ago was with systems 15 years old. Today's systems at low cost on ticketless systems have become as safe as large-scale systems were 15 years ago. This is the other challenge. How many alliances do we have to join? How many wireless protocols do we have to support when what we really want is super low power Wi-Fi, super low cost Wi-Fi on everything? And that's the challenge that a lot of our customers face building products for the IoT. But there are other standards. One of the most exciting is Bluetooth Low Energy, Bluetooth Smart. Bluetooth Low Energy promises very, very tiny battery devices of the order of square centimeter or cubic centimeter with integrated battery that can live on battery life for 3-4 weeks. But as we start to add what's called mesh software above the application layer, we can start thinking about now, instead of just a point-to-point to a headphone or keyboard, we can now thinking about hopping around a home, just connecting to Bluetooth devices. So when you see a lot of IoT devices that may plug in your wall socket or may go into your smoke detector socket, what you're really looking at is a way of installing a mesh communication network around your home. You may think you're looking at a smoke detector, but you're really looking at home automation. And what the latest movements in Thread and working with Nest are showing is that you can take products out of the box. You can buy products, take them out of the box, and have them work in the home. We feel that products that don't work out of the box will not make it. Products that need technical calls, installers, tech support will not make it. 8 to 10 years ago, your home residential gateway would need several tech support calls to get running. Now they come out of a box and work, and if they don't, you send it back. So that's exactly what's going to happen with IoT devices. If it doesn't work out of the box, it isn't going to sell, and you're not going to phone tech support to get it working. That's going to put huge onus on ourselves and our customers to get the software right, to use software that works well together, to not put out software or services or products that are not fully thought out and fully part of larger alliances. No one company, no one customer can make this happen. Nevertheless, all those industry alliances exist. We have to participate. It's a huge burden, and some of those will become successful and some will drop by the wayside. But the history of multiple standards always shows that the market ultimately makes a choice and comes down to less standards. Right now we're in a point of maximum diversity, but expect to see this start to coalesce. But that's the simple area. Now you have the alliances of interoperability. So now it's the Wild West in that area. Which device can work with which device? So that's why Thread is so important to us. We were one of the 7 founding members of Thread. That original 7 founding members has expanded to 11. The first 10, 15 additional members joining have now become 220, and this was about 2 weeks ago. And there are more than 2,500 companies currently researching and deciding whether to join Thread. So we see this as the biggest alliance yet. At the lower levels, the actual 802.15.4 levels of connectivity. Above this, we can see the application levels, and here there's probably a future for Zigbee, where Zigbee profiles for medical, for home, etc., can run on top of Thread and actually move away from the original Zigbee physical layers. What you have here is Moore's law. You've all heard of Moore's law. What you have there is more than Moore, which some of you may not have heard the expression, but it's exactly what it says it is. More than Moore means integration of a whole bunch of useful stuff that isn't being driven by the normal Moore's law. Now, why is that different? Well, analog designers, sensor designers, RF designers, high voltage designers, they hate Moore's law. They literally hate Moore's law because it takes them 2 years to get their stuff working and another 2 years to improve it. And when someone comes along halfway through that and says, oh, time to change process, they just hate that. So what designers in this field love is continuity. They love things that last a long time. That's probably the only reason there are still semiconductor fabs around that belong to semiconductor manufacturers. It's the only reason we haven't gone totally to foundry. But what's happening here is now becoming very discontinuous, very, very difficult to deal with. And so we see more and more now, sorry for the pun, we see more and more systems being engineered to specifically take the advantage of integration of RF, of very high quality mixed signal analog, where in the past the mixed signal analog on board a microcontroller didn't match up to the dedicated analog parts. Here you see a crossover where you see system in package being really relevant. And on both sides you see more integration being really relevant. Now, why is that important? About 18 months ago I did a mixed signal summit at Cadence. And I basically said, the title of the presentation was 28 nanometers, the last simple node. If you're in analog design, you would have thought I was insane. And if you're in microcontrollers, that's pretty advanced. But here we are today, and we're looking at 28 nanometers for microcontrollers. But this is the point at which it gets very disruptive. From here on in, it gets to be hugely expensive and not really predictably coming down over time. And it also gets to be more and more complex to manufacture and predict how the product performs. So there's kind of a end of evolution here, where it tells you that at 28 nanometers, it makes more sense to invest heavily in more than more. Makes more sense to figure out how to do MEMS sensors, how to do really low power RF, and really useful integration on silicon. So this is the NXP, the former NXP LPC microcontroller roadmap. I was there at the start of this. In '99, we had to decide on a 32-bit architecture. The prevailing architecture in Philips at the time was MIPS, but we decided with the help of our distributors and the emergence of ARM as a formidable IP source, that ARM would be a better choice. And coincidentally, at that time, Philips acquired VLSI, and VLSI was a founding investor in ARM, the IP company, together with Acorn and Apple. So that brought many years of experience with ARM IP, fabric IP, physical IP, as well as cores, all into the Philips umbrella in late '99, early 2000. And we launched the LPC microcontroller family in 2002. Great history of innovation in the LPC team, largely headquartered out of San Jose, California, with a small part of the design team in Shanghai, China. That team joined the Freescale microcontroller team as of the 1st of this year. So we all are now in one organization. That's very exciting for me, putting together my old microcontroller group with the new to create something I hope is better and even more innovative than before. And we're really going to get to the core of the innovation that this group had. The first group to use the Cortex-M0 in a product. The first group to introduce an ARM7 or even ARM-based microcontroller with flash in 2002. So to continue that tradition, that's where we'll focus this team. This is the former Freescale product line, the Kinetis microcontroller and the i.MX families. You see here, each one of these blocks of Kinetis is as large as the LPC family. So the first thing that you see is scale. 1,000 R&D engineers, 1,400 people in the organization, including a large test engineering team for manufacturing. The Kinetis K series, the first Cortex-M4 to be launched on the market. Kinetis L, the first Cortex-M0 Plus on the market. Put those two together, you have pretty much firsts in all the Cortex-M classes except the M3. Kinetis W, our latest range of multi-mode radio. I mentioned those standards on previous slide, 802.15.4, Thread, as well as BLE. This is the first part on the market with multi-mode radio with dual network capability. So with one radio, we can be coexistent on a BLE network as well as a Thread network. Imagine an application like hotel e-check-in. You may have seen that on a number of the major hotel chains, where you online can get your e-check-in voucher directly delivered to your mobile phone, and then walk up to the hotel door lock. The BLE pairs automatically, opens the door lock, but the door is part of a Thread network as well. But they're not necessarily concurrent, or the 5 milliseconds to switch between the two is easy to accommodate within the network. So, as I said, in all those applications where you don't need dual radio, Kinetis W is the first family that allows you to do BLE and 802.15.4, whether it's Thread or Zigbee, in the same part with just one radio. Another unique innovation. And then you have i.MX. I mentioned 2 years ago, 200 million, now $500 million. Expanding faster than any family we've seen before. 4 years ago, just 4 IMX6 products, now 11 products. We're going to continue to develop IMX6 for ever lower cost. We're starting to show the product IMX6 UL, and then we have 2 more IMX6 products in development at even lower cost. We've just launched and released the first IMX7, which is taking advantage of the new 28 nanometer nodes, and in particular, the fully depleted silicon and insulator node, which is going to make huge improvements and advances in lower power, not only lower power dynamic operation, normal mode, and many, many more grades of normal mode, as well as much lower leakage, potentially over the next 2 years, reducing the leakage by 10 to 20 times. So we intend to be able to produce application processors that have the kind of power characteristics that you see on today's microcontrollers. We did this merger to get bigger. I said that at the outset. We didn't do this merger to get smaller. We love working with customers who keep products going for 25 years. That's cool. We also like customers who use new parts earlier. We don't have enough. We'd love to have more customers use new parts earlier. But it takes time, I realize, to get things designed. So we're there to help you get stuff to market sooner. And on the IMX side, one thing that's become obvious is advanced graphics are not easy. And we have many customers who do just fine on advanced graphics, and we have many new customers who are new to it and kind of struggling. We have a lot of graphics designers. We have like 36 guys in our graphics technology engineering center. And recently we added some cool guys. So we added a guy who did the graphics on Kung Fu Panda 2 for DreamWorks, and some guys that did the latest Madden game for EA. And why did we do that? Well, we did that so that we could show customers what was achievable in single silicon that typically you see done on a supercomputer frame by frame and put into a Hollywood movie. So we have everything from the enablement, expert engineers for tech support. We have systems that help you bring products to market quickly. We've unified our Yocto Linux delivery across the whole company, including digital networking and our automotive, radar, and vision groups. We have one Yocto model now, and the teams cooperate. And then we have software and professional services. And the idea there is to take our customers' products and differentiate them quickly to a level that gets them an advanced position in the market. Okay, I tried to cover longevity, the true meaning behind the merger of NXP and Freescale, and where we really want to head in terms of leading the way in networked connected products, with security and privacy as our top priority, helping customers to get all of these systems to the market over the next decade. And when the hockey stick comes, what we have today is going to look like that first 20 years of mobile phone.